Good morning, distinguished guests. Good morning, ladies and gentlemen. Thank you for the introduction of my person. So you have got an overview that my main focus is teacher training. I would like to thank you, the organizers, for inviting me to this Congress, and I would like to congratulate the organizer for this Congress. It's running parallel to the BIP Congress in Germany, which is also going on today. In my presentation, within the title Digitalization of TVET, its success, challenges and opportunities, I will cover three main areas. The first, the need of sustainability in all our actions and the relation to TVET. The second, the requirements of the digitalization in the field of Industry 4.0 in the production industry. And third, how the answers of TVET to all these requirements might look like, with a main focus on digitalization. VUCA, volatility, uncertainty, complexity, ambiguity, describes the manifold developments our society is confronted with, specifically for education and TVET. This means that we have to find answers to the requirements because of the changing world, because of sustainability, and because of digitalization in all of our areas we are active. This means we have to make clear how TVET centers could get more efficient in the output quality and what they can do for inclusion. And the next, what excellence in TVET means due to the changing work in technology. And the next, how to support flexibility in the design of curricula and TVET training itself. And how to implement ecological requirements, ecological questions into TVET training and TVET profiles in order to support sustainability. And how to ensure efficiency in training by ensuring an educational process. What we are discussing today is not new. Already in 1972, a German minister has opened the debate on questions concerning our future, the future of the whole planet. He was asking whether more quality of life means ever increasing wider roads for more and more cars, more and more larger power plants for more and more energy consumption, more and more larger airports for more and more expanding air travel, more and more pesticides, ever more people, and so on and so on. Today, 50 years later, we are still fighting for the final answers to these very fundamental questions. TVET is one of the areas which will be deeply confronted with the answers to these questions. All the resources we have available in a year are already used by July of each year. So for this year we have reduced all of the resources which are available for us already. This means that we are living today at tomorrow's expenses. To put it very simple, we are stealing the resources of the next generation. I do hope that all guests in the room are aware of this situation. It is high time to bring together the three dimensions: economic efficiency, in which we are all interested, social responsibility, which is very important for life, and ecological compatibility in a maxim which calls for action. Their impact should be compatible with the permanence of real human life in our planet. All destruction of future opportunities of life on this planet has to be avoided. Many strategies, many frameworks and political activities are available to support sustainability and education and training. In Europe, we have developed a green framework and greening TVET initiatives which were worked out by the European Union, but not only by the European Union, also by the European member countries, and very important, by TVET institutions. We have a European Green Deal, and we have the UNESCO Strategy for Education and Sustainability Development for 2030. In addition, we have some more frameworks for teacher training, for greening occupations, and we have a degrowth society. A new environmental movement are TVET congresses under the title All Days for Our Future. Just 3 weeks ago, we have had our TVET Congress in Germany under the title All Days for Future, which is coming up more and more. The idea behind this movement is to support the shaping process to build up an environmental friendly world. The overall model which is behind these activities is a so-called socio-technological model. It demonstrates that we need an excellent balance between the technological development, the work organization, and the education to ensure human-friendly socio-economic developments. Only a balance of the 3 pillars mentioned can help to avoid destruction of the planet. In 1972, the Club of Rome has already made it clear that we are confronted with the limits of growth. Beside of these limits, which mainly means no further use of fossil raw material, the primary target for TVET has to be to shape a human and ecological-oriented digitalization for the future. This process must be driven by TVET, by education, by politics, and by the elites. The scenarios which are shown in this slide might help to identify our future direction. The so-called automation scenario or the expert scenario. The automation scenario is very much technological driven, and that's the situation we are in just now. There are almost no chances for skilled workers to shape this technology. They only can make use of it. For the ecological dimension and the social dimension of sustainability exists clear limitation when it comes to the further use of these scenarios. In the expert scenario, human beings are in the center of all of the decisions. Should the development process go on in this direction of the expert scenario, and should human beings maintain their capabilities of shaping technology and work processes, they are in the position of taking over responsibility. The chance for an increasing role of sustainability seems to be very high within the expert scenario, and that's the reason why we are favoring the expert scenario. As for TVET, the shaping process means to bridge TVET education with sustainable requirements. The ecological triangle has to be the leading idea to ensure sustainability. In many working areas, skilled workers have a lot of impact on following the ecological triangle. The skilled workers are able to influence the use of environmental friendly insulation materials when it comes to building a house, for example. Skilled workers can align the electrical energy systems of a house in an energy-saving way, as for example implementation of smart houses instruments. Skilled workers can also support recycling processes and a lot more. In the next step, I will have a closer look into digitalization in the production industry, and especially in Industry 4.0, as a field of application of digital instruments. So the understanding of myself is that Industry 4.0 is the application field of digitalization. So core questions are still under discussion. Which job profiles will be needed for future work, and which competences do the employers need in the future? Digitalization is being driven forward because of increase of production, and it enables Series 1 production. Digitalization as an Industry 4.0 application is an automation tool. The expectation of the factory planners is that quality and quantity in production can be improved, and therefore more highly qualified employees are necessary. It has to be underpinned that the expectation is more highly qualified employees. Many studies document a high risk for workplaces if Industry 4.0 will be implemented. As for Germany, OECD estimates that around 18% of the workplaces are under risk, and around 35% of the workplaces will change. But we have also some other studies around, for example, from the Labour Institute. Science studies say that only around 30,000 to 50,000 workplaces get lost till 2025 out of 42 million workplaces. That means less as 1% only. But from study to study, we have different outcomes. For the ASEAN market, a key figure from 2016 is that 60% of the salaried workers in Indonesia, Thailand, Vietnam, and the Philippines in the electrical and electronical industry are under risk. In our studies, and studies from some colleagues in Germany, the outcome is that simple routine activities and such workplaces are no longer relevant. These workplaces are highly under risk. However, highly qualified skilled workers are more in demand as before because of the complex production processes. The McKinsey figure of 2017 is very realistic as according to the findings, approximately 14% of the global workforce is confronted with changes and risks and need transition to new occupational categories. Therefore, the workers have to be qualified, and upskilling will be an important task TVET centers have to fulfill already today and in the future. With the next slides, I will go a little bit deeper into some outcome of research in the production sector, mainly in Germany. I will not talk about the research methods we have used, I only will come in with the outcomes. One of the main characters of digitalization and Industry 4.0 is the growth in data. The duplication of the performance of computers every 18 months allows to create complex system networks which are integrated in the production machinery. This leads up to the production which is controlled by data. Skilled workers have to be trained in troubleshooting and repair these networks. When it comes to the implementation level of Industry 4.0, we have identified 4 company categories in the German market. Category number 1, type number 1, it exists of around 20% of the companies, is still producing in the same way as they did it 20 or 30 years ago. Type 2, another 30% of the market, makes use of computer technology in a very simple way. Many times they produce intelligent products like 100% automatic sewing machines, for example. Type 3, around 30% of the market, has optimized their production and monitors it with software and data by using, for example, MES or ERP software, which is very common in the industry. This type we could categorize as the type 3.5 when it comes to Industry 4.0, and type 4, another 20% have reorganized the production and use cyber-physical systems and networks. Type 4, that means around 20% are the only companies which follow the fully Industry 4.0 principle. Disruption, which was for a very long time under discussion, does not play any important role in these implementation steps. The implementation of Industry 4.0 concepts in companies is a step-by-step process. When looking into technology which has been implemented in the meantime, we can state that most of Industry 4.0 instruments are in use in companies, with the exception, and the exception is very important because especially when short films are shown, as we have seen just a few minutes ago, a different signal is given. With the exception of, for example, artificial intelligence. In the production industry, at the shop floor, artificial intelligence does not play a role up to now. Also, virtual reality does not play a role up to now. And digital twins do not play a role up to now. That's a typical instrument for the developer of the production. Robots, process visualization, use of different software, use of different data is a very important area which is covered by skilled workers at the shop floor level. This implementation level of digitalization technology requires that skilled workers have to be trained in the use of these digital technologies. And this is something different as to train them in digital media, in the use of digital media. Digital media is one of the areas which is important to train teachers, but skilled workers we have to train in using digital machinery. On the right side of this slide, you will find an example of the implementation of a 6-axis robot which was implemented by skilled workers in a small and medium-sized industry. And for skilled workers, it's a very normal work task in the meantime to implement such digitalized instruments. On the left, there is a summary of tasks which have to be fulfilled by skilled workers in an Industry 4.0 production. For example, they have to operate a mechatronic plant, or they have to operate several mechatronic plants at the same time. They have to optimize the digitalization process in a company. They have to analyze the production data and to work with this data. They have to communicate in heterogeneous teams. They have to carry through parameterization to bring machinery into a running process. And all these requires well-trained, skilled workers. The example of welding underpins the importance of skilled workers in a digitalized work environment. They must have the know-how for welding, as in the past, and they must be able to program a welding robot for an optimized welding process. So they have to combine very traditional competences with the latest competences. However, the software of the robot has to be designed in a way that skilled workers can work with it. And for this, they have to use a so-called low-code programming, which drives the engineers crazy because it's not very simple for them to produce low-code programs which can be used by skilled workers. So the next slide looks a little bit complex. I'm aware that you cannot read what's written over here. That's the outcome of the analysis of a automotive manufacturing company in Germany. And the message of this slide is that when it comes to Industry 4.0, when it comes to work at the shop floor, not only technology, not only work organization is important. The social implications are very, very important for the workers. That means workers have to be able to cooperate. Workers have to be able to communicate. Workers have to be able to improve the quality of the production. Workers have to be able to make changes for a better work, and workers have to be able to come in with innovations. And these social components have to be brought much more into the center of training activities as in the past. This skill radar is something like a summary of the competencies which are under discussion nowadays. The image shows a skills radar which gives an overview of competencies which are relevant because of digitalization and Industry 4.0. 3 categories of competencies are very important. On the one side, the so-called context-specific competencies. For example, design of a digital process or troubleshooting in a welding robot. The second, new broad competencies because of digitalization. That means work with multiple data formats, carrying through data management as an example. And third, abstract competencies like communication, collaboration, innovation, management, etc. The third dimension is comparable to what was called in the film 21st Century Skills. All 3 categories are important for skilled workers, and these competencies have to be developed in training. I'm not going deeper into this slide. It should be only a motivation for researchers to carry through long-term research in the production field. The origin of this slide is from the manufacturing industry from Malaysia. It's about 16 or 17 years old, and it would be interesting to know whether the distribution of the level of skilled workers, semi-skilled workers, highly skilled workers is the same today. And important in this, and this makes the job a little bit simpler, would be to use the same empirical method as we have used at this time. In this table, you can see changes in the manufacturing world over the last 30 years. In the 80s and 90s, the so-called C technology, the computer technology, was introduced into production. In 2000 and 2015, the process optimization in combination with the use of software was in the center. And nowadays, networks and physical systems are introduced. In the 90s, it was important to develop skills to handle computers, and we have had a similar discussion we have today because of digitalization. Nowadays, skilled workers need to learn to think about the use of software based on the processes in the production or in other units. This seems to be abstract, but it is reality. The question is what we have to do, what we can do. Now I bring in an example which is running already in your area of the world. I bring in an example of teacher training from RECOTVET. In the GIZ program RECOTVET, a multiplier training for TVET teachers was organized for the field of Industry 4.0. Beside from training in action-oriented learning and curriculum design, the training was organized in the technical field of Industry 4.0 in cooperation with the Thai German Institute and against the background of Industry 4.0. The training covers around 4.5 weeks and is offered in a mix of online training and presence training. The training follows the concepts to train teachers from the level of beginners in Industry 4.0 to become an expert in Industry 4.0. With the help of the so-called learn and work assignments, all training is monitored and related to the work requirements, and this is very, very important. Within the learn and work assignments, work relations are ensured. Learn and work assignments are the backbone of this type of training. If you are interested in more details of this training, Ms. Siripun, who is sitting here in this room, can inform you of all of the details. If you want to start action, today with training your students and staff, please create a so-called shadow curriculum. A shadow curriculum runs along with a standard curriculum and should be created by teachers, by curriculum managers, by TVET center managers, by finance managers, and the students. For this action, it makes sense to organize a meeting point where the group can meet and create ideas for the shadow curriculum. For a detailed training program in digitalization and Industry 4.0, there are 10 steps to create this program. The areas you will have to work on are shaping of occupational profiles and curricula, taking care of the requirements of the industry in the design process, and initial upgrading of teachers and trainers as one of the most important steps. And this should be the first step you start with. To bring the outcome of such process into the process, my recommendation is to work with alliances for supporting digitalization and sustainability in a wider sense, and to promote dissemination of training. I recommend to establish alliances, not only networks, for a close cooperation in training and learning. The work in these alliances should be human-centered. The character of alliances is that a close cooperation and collaboration is established in combination with mutual support of the partners. I'm at the end of my journey through the innovation and use of technology in the last decades. Thank you very much for listening.